Hey guys, in today's video we will look into PLC and SCADA side of our project. I hope everyone is familiar with the PID in PLC systems. I'm not explaining too much about those in here. If you have any doubts, please let me know in comments and I will make it clear in the next videos. It's a lengthy topic to discuss here. So let's move on. For Siemens PLC there are many types of inbuilt PID controllers. Here I have PID Compact and PID 3-step. For this project I am taking PID Compact. For adding this PID Compact we just have to click it. Normally PID blocks are added in the cyclic interrupt blocks because cyclic interrupts are always called at a regular interval of time even if there is any problem with the main program execution. So I have added the PID blocks in the cyclic interrupt block OB30. Here I have already added the PID compact block and I have already configured the input and output parameters. I'm going to explain each and every point one by one now. First one is the set point. This is the point which we want to be the level of the tank. And the next one is the input level. It is given by the level sensor. In the last video I told you that I'm running this in a simulation mode, so I don't have a level sensor now. So I created a small program in my second cyclic interrupt block. This cyclic interrupt will give me a simulated input level, that is this one acts as the level sensor in this program. Next tag is the disturbance tag. Disturbance tag is defined as the value which cannot be controlled by a PID block, PID system. For controlling the disturbance we need something like cascading PIDs. That will be another topic. The next input is the manual enable. This button acts as a override to the output value, that is if we enable this button we can change the output value to any value which we want. The next input is manual value. If you want to change the output to our desired value, we have to give that value at this point. Then we have to enable this manual enable. Then only the output will be changed to our desired value. Then comes the error acknowledgement input. If there is any type of error in this PID block, this error bit will go high. Then we have to acknowledge that error by giving a high input at this point. Then comes the PID reset input. If there is a false to true edge at the PID reset input, three things will happen. The PID block will be switched to inactive mode and all the error bits and warnings are reset and the integral action will be cleared. If you are familiar with the PID system, you know that integral actions are accumulated over the time. Once it is reset, the integral actions will be cleared. Next one is the mode active. Before that I will tell you what is a mode. Actually there are 5 modes in this PID compact. First one is mode 0, the inactive. That means the PID block is not active. Then the next one is mode 1, is pre-tuning, and mode 2 is fine-tuning. Pre-tuning and fine-tuning are done only at the beginning. Once the systems are tuned, there is no need to tune it again normally. Then comes the automatic mode, that is mode 3, and the mode 4, which is manual mode. These two modes are we use normally. If we press PID reset, then the mode will go to the inactive mode, that is mode 0. So activating a mode, first we have to give which mode we want at this point, and then we will give a false to true edge at this point. Then that selected mode will be active. So these are the input parameters of this PID compact. Now we will check the output parameters. The first output parameter is scaled input. I will explain about the scale input value when we are running this project. Then comes the output. This will be the output generated by the PID itself. Then there are 4 warning bits like set point limit high, set point limit low, input warning high and input warning low. I'm not using these bits, so you can read about those in this help file. If any doubts, please let me know. I will make it clear. Then comes the state. State means which mode is currently active, that will be shown at this state, nothing more. Then comes the point error. If there is any error, this parameter will be go high, that is false to true. And we can understand what type of error it is by seeing the error bits at this point, but I am not using this on this project. Okay, so these are the output parameters. So these are the input and output parameters of this PID compact block. So in this we have used 8 input parameters and 4 output parameters and 1 input output parameter. All of the details are available in the help files. You can read if you have any doubts, and still it's not clear, please let me know in the comments. I will make it clear for you. Now we'll check the SCADA side of the project. After that we will configure this PID compact. Okay guys, now we will look into the SCADA side of our project. Here I have already set up a tank which is assumed to have a capacity of 1000 liters and 2 pumps, one is for in and one is for out, and 2 lights for seeing the current status of pumps, and 2 switches. This is for the input pumps, this is for the output pump, and this one is for seeing the current flow level, which will be controlled by the PID itself. If you want, we can change it to manual also. That will be displayed here also in this column. And this one is for controlling the output flow. It can be changed only manually. Then I have already connected all the relevant points from the PID blocks, as you can see now. Set point, input level, disturbance, and everything is connected here. And besides that, there are 3 columns, for one of which is gain and TI and TD. This will be explained after explaining the configuration of PID block. For the level animation, I have already created a small blue color bar under the tank. It will be animated when the level starts rising. Okay, so that's the SCADA side of our project. One thing I forgot to tell you, that in my main block there are some programs. This is for the displaying level, just a conversion block, and these 3 blocks are for the gain, TI and TD for display, and 1 block for the date and time. This will be used for the data logging. That will be explained when we are running this project. So that's it. This is our PLC and SCADA side of this project. Now we'll configure the PID block in the next video. Thank you.